Hello everyone. In this video, I'm going to talk about spam detection with the help of machine learning model, where we will build a machine learning model to detect a SMS is a spam message or a normal message. Before getting into Python implementation, let's understand the steps. So what are all the steps that we need to carry out during this spam detection on creating a spam detection model, right? The first and foremost is basically read data set and make it in proper format. So we are going to read the data set and we'll make it in a proper format, right? Then comes encode labels. There are labels which are in the form of a text and we are going to convert into some kind of a numbers. So that is basically what we are going to do in the encode labels, right? Convert all cases to lower. So in order to pre-process the data, we need to make sure that all the text are in same case. So we will have a caps and a lower. So we want to make everything in one case. So for that, we will convert all the cases into lower case and remove punctuations. We have understood what are the punctuations, and punctuations doesn't give any meaning. So we are going to take care of that one and we will remove that. At the same time, removing stop words, as we know that stop words also doesn't give much of a value. So we are going to remove the stop words as well. And we are going to do some kind of analysis, right? Checking the messages and things like that. So we'll see that how we can do and convert all text into vectors. So we are going to do some vectorization here. We will apply some technique and we will convert those all text into some kind of a vectors, right? That is a word embedding. That is what we have understood. So we'll see that how we can convert them. And as usual, importing the classifier, then applying a train test, right? So we are going to divide the data into train and test and applying our model on the train to train the data. Then we are going to test it. Once it is done, yes, we are going to check the accuracy of the model. All right. So these are all basically steps that we are going to take in order to build a model. So from 1 to 7, it is all about a pre-processing data, right? So data pre-processing, after that, this is model building, 8, 9, 10. All right, let's start. So here I'm going to import necessary models. As of now, I'm importing pandas, NumPy, Matplotlib, and Seaborn. And yeah, this warning is just to avoid any warnings to be printed on the within the Jupyter notebook. All right. So now let's start. I have a data set which is related to spam. Okay, so in that what have, let me remove this, give me a second. So the data set is having good messages as well as spam messages. So I need to study all the messages and build a model so that whenever a new message comes in, I will be able to detect whether that message is a normal message or a spam message. That is the idea here. All right. Let's import the spam data set here. And I'm going to apply a pandas method here to read the data set. And I will print the head method. Let me execute this first. Okay, now I'm going to execute. And as you can see, there are messages that says ham and spam. All right. So ham and spam is basically, give me a second, why it is not printing. Sorry about that. Yeah. So ham is basically a good message or a normal message, and spam is a spam message. Right? These are all the messages, and we have some unnecessary columns here. All right. So we are going to get rid of that. We'll see that what and all we can do. And also I want to give some meaningful name for these columns. All right. Let's proceed. Okay, now as we know that unnamed 2, these guys, right? Unnamed 2, 3, and 4 are unnecessarily coming in this data set. So what I'm going to do, I'm going to drop them. SMS is our data set, and I will say SMS.drop, and the column names is what I'm giving, and they're all on axis equal to 1 column wise. And also I'm saying in place equal to true so that the changes can be saved permanently. Right? And at the same time, I'm taking these two guys, V1 and V2, giving some meaningful name, right? So for that, my data set, SMS dot rename method I'm using, and where I'm giving a column, right? Columns basically should be in the form of a dictionary here. So V1 is one of the key here, all right? So for that, I'm renaming V1 into label and V2 into message. So I'm separating with this comma. And here also I'm saying in place equal to true so that the changes can be saved permanently. All right, let me execute this. And now I'm going to print the head method. So this is how the data set looks like. Label, message, and I have taken care of these unnecessary columns, right? So now let me check the shape of this data set, sms.shape. So it is having 5572 rows and 2 columns, right? And now I want to check how many ham and how many spam messages are there. I want to just to know the count of those guys. So for that, what I'm going to do, this is my data set, SMS dot label dot, right? Label is my column name, right? Dataset column name, and there I'm using a value underscore counts, right? So this will give the counts of each label. So let me execute. As you can see, ham is having 4,825 messages and spam is having 747 messages. All right. So that is the count I have for this ham and spam. Now I want to check the ratio of each ham and spam. So for that, what I'm going to do, let's understand this. I'm selecting from main SMS dataset. So in that, I'm checking this condition. In this SMS, where label equal to spam, right? It is going to filter only spam data. Then divided by, so SMS dot label. So total number of messages, right? So only spam messages divided by total number of messages. I'm using this into 100 to get in terms of a percentage, right? So length is basically total length. First, I'm going to get the total number of labels so that I will be able to get it using a length function. Similarly, ham messages divided by total number of messages. That will give me the ratio. So spam is having a 13%, ham is having a 87%. All right. So now what I'm going to do, I am going to create a new column called length. So here I want to check the message length, right? Each message length, just for analysis purpose. And later we can see that how we can interpret this original or raw message length with a clean message length, right? You'll get to know. So here I'm creating a new column called length. There I'm storing SMS.message. Message is what? Message is our message column. So in that column, I want to check the length of each and every message. All right. For that, I'm using str.length. Length is the function that we know. So I'm going to find the length of each and every message and store it in new column called length. Let me print the final data set here. So as you can see, length is a new column, and there I have stored each and every column, each and every message length. It means that, so length of this message is 111, length of this message is 29. so and so forth. Right? Let's move on. Now, what I'm going to do, so we know that our machine learning models will not understand any text. So I need to convert the text into numbers. So right now I'm going to convert these labels. Here we have only two classes, ham and spam, right? So I'm not going to going for encoding methods. Since we know that only two classes, I can simply use a replace method. So I'm selecting sms.label, right? This particular column I'm selecting, and I say that dot replace. So there I'm saying ham should be replaced with 0 and spam should be replaced with 1. And again, I'm saving the data set permanently, right? So in place equal to true. So let me execute, right? So that is what I have done here. So ham will be replaced with 0, spam will be replaced with 1. So in the next step, I want to convert all these messages into lower cases. As you can see, G is caps in caps and O is in lower. So since all our machine learning and everything is basically case sensitive, right? So I want to treat all the messages in a treat same. So for that reason, I want to convert all the messages into lowercase so that I will not get into any trouble while converting or while checking the messages for any reason, right? So for that, what I'm going to do, I'm selecting the data set and selecting this message column. There I'm saying string str dot lower, right? Each and every message will be converted into lowercase. Let me execute. So I have taken care of this and I have taken care of lower as well. Let me print. So yeah, you can see that all the messages have been converted to lowercase and labels have been also converted into the respective numeric number 0 and 1. You can call it as a binary classification. All right. Fine. So now let's continue our pre-processing step. So regular expressions. So we want to remove some regular expressions. At the same time, we want to remove the punctuations also. All right. So now here what I'm trying to do, I'm trying to remove email addresses, right? So because in spam messages and all, sometimes we feel that sometimes we know that spammers will send some email addresses to send to ask a person send your bank details or things like that, right? To this email ID and all. So wherever we see this at the rate, right? Wherever we see this at the rate, and after that dot, comma, dot com and things like that, right? So here I am selecting this message column and I'm replacing wherever you see at the rate and after that dot. So com will be inside the A to Z. So we have understood the regular expression part in our earlier videos that how to fetch only particular data. Same thing I'm using here. So, and at the same time, I want to replace such type of a data into email address so that I can interpret that in a later part. Okay, there was the email address present so that I can identify and so that I can treat that data differently. All right. So I don't want to remove everything. I want to identify that email address, the real email address, and basically replace with the clear text because at the rate dot com they will not make any sense. All right. So I just want to replace with email address. Similarly, URLs will be there. Like okay, you have won the lottery. You click this link to claim your prize. Right? Something like some kind of links also will be shared with us by spammers. So I want to identify that such kind of links. So which always start from assuming that they'll start from HTTP. So in between, I will have a numbers or a text, right? And it could be anything. So that's why I'm using everything. Small case text, capital caps, if and if there are any numbers or if there is any hyphen, right? So I'm covering everything. So wherever we find such type of data, I want to replace with a web address so that I will understand that, okay, there is a website link was given. So that will lead us to some kind of analysis, right? So that is I'm taking care. And wherever I find this symbols, dollar, a pound or yen or whatever it is. So here I'm using only two. So if you find this kind of a symbols, you just replace with the dollars because this will not make any sense to our model. So at the same time, I don't want to delete. I want to make sure that what are all the details given in the spam or a normal message. I need to understand that whether there is a dollar symbol present or not, right? Something like spammers asking you to send some money, some dollars, some rupees. So I want to identify such type of a data. So for that, I will identify and I will replace with this text. Same thing goes with the phone number. So this is the format they follow in US. 3 hash, sorry, this is how it is. Let me write it. So there will be phone number, the format they follow 1, 2, 3, 4, 5, 6, and 7, 8, 9, 0. 3, 3, and 4. So in between we have a dash here. So that is what I'm trying to do here. So 3 dash, then digits 3, then dash, then digits 4. Right? Wherever you find this format, which are all digits, then you replace with the phone number so that I can understand that there was a phone number given in the message. Otherwise, what will I do with this number, right? When I'm pre-processing, when I'm building a model, these numbers are not going to help us, all right? In fact, they will lead us to in altogether in different direction. So this is the reason I am changing it to phone number. And wherever other digits, any other digits you come across, then you replace with this text NUMBR. You can give different name also, not at all a problem. All right. So that is the idea here, and let's move on. So here I am removing the punctuations, strings, and uh, words, digits, and things like that. Give me a second. I will choose the pen. Okay. So as you can see, there is a caret symbol, right? So not equal to. Caret means not equal to. So wherever it's not equal to words, digits, and spaces, so you replace with this space. Similarly, S plus is between the single space, between terms, single space. Wherever you find that, you replace with a space. And remove leading and trailing white spaces. All right, so that also I'm going to replace with simple spaces. All right, so that I want to keep my data clean. Right, let's move on. So I think I did not execute this. Let me execute and let me execute this. Finally, I will print this. Right, so my data is basically clean, and still I have some more steps to take care. That is removing the stop words. Right? Here I'm importing a string, NLTK, and stop words. So what I'm going to do, I'm going to use the stop words, and also I'm appending, I'm adding some more stop words, which I feel that maybe this kind of words or letters will present in a messages, because sometimes we use this kind of data, right? So for instead of writing FOR, so we'll just message like a F, I know, just a numeric. And instead of using a TO, so we use a 2. Like instead of FOR, we just write it for. Instead of 2, we'll write it 2. And instead of writing YOU, sometimes you will write U only, right? Instead of writing YOUR, you will write just UR. So considering that, so I'm just adding some extra stop words because these guys will not add any values. So you can extend this list however you want. So everything will be stored in this stop words. Now I'm selecting my message, this guy. So I want to execute some expression here. So the final result will again store in the same column. All right. So here, very simple. I'm selecting this message and I'm applying to a lambda function here. In the lambda, so what I'm going to do, I'm going to check. First, I'm going to split the term, right? For every term in x dot split. X is nothing but this message. Again, this will be passed here. And I'm going to split it. So go until Jurong, point, crazy, available only. So the data will be split in this fashion. So after splitting, right, one by one, so I'm going to check if that term, if this term not in stop words, right? If this go is not in the stop words, then only I'm going to pass it. I'm going to store in message, right? One by one, each and every word will be stored. And here I'm using a join, so that will make sure that they are joined together in the same line, right? So that is what I'm going to do in this section. So finally, let me clear this. I'm creating one more column. So that is basically clean length. So what we have done until now, we have taken care of all the pre-processing. So still one more, a couple of steps are there. So at least removing part, right? Data cleaning part we have done, right? Data cleaning part we have taken care. So now I want to see that the clean length. After cleaning all the junk data, I want to see basically the length of cleaned data. So for that, I'm creating one more column. And here I am giving the length function, just like how we use this same code for a length for this guy. Same thing I'm using here. This time it is going to be new column, clean underscore length. All right, same data we'll get it. So this time we'll have a different numbers because we have cleaned some junk data here. All right, let's execute. Now I'm going to print this head. So you can see that original length was 111. Then we have cleaned the data. So after that, the cleaned data is basically 82 for this particular message. Similarly for other messages. All right. So next I'm just comparing original length and clean length. For original length, just a length dot sum. For clean length, clean underscore length dot sum. As you can see, how much junk data we have removed, right? So if you look into this original length, we have 4,46,422, wherein clean length is having a 3 lakh odd, right? So almost 1,50,000 junk data, or I would say text or the letters we have removed. All right. So as you can imagine that, so if the data set is having millions and millions of rows, you can imagine that how much junk data we would have passed to the machine learning model. right? So that is why it is very important to clean the data, right? So let's move on. So here, what I'm going to do, I'm going to check the data distribution, right? So how I'm going to check the data distribution? I got a length and I got a clean length, all right? And what I'm going to do, first I'm going to take the length here. So I'm going to use a distribution plot. So I'm selecting label equal to 1 and label equal to 0 here. So I'm going to check the raw length, raw message length, and I'm going to plot the distribution plot and see how the data is distributed, right? So these are all basically matplotlib techniques. So I'm not getting into individual line here. So it's very self-explanatory. So you can go through this, right? So let me execute this. So this is how the data distribution looks. So this is a spam SMS length and this is a ham SMS length, right? So now same thing I'm going to do for the clean length. So this is basically what? This is basically a length. And now I'm going to use a clean length. Nothing is going to change except this length column. Right now I'm using clean length and the distribution looks like this now. All right. So it's just for analysis and you can see that ham SMS length is around 400 odd, maybe 500 you can assume. But here you can see, right, it is almost 900, I mean, right? So much of junk data was there and we cleaned it up. After that, we see that so much of changes in the distribution. All right. Now I'm going to import a word cloud. So word cloud is basically help us to get a sense of loud words. Right? If it's occurring more number of times, any word, it will be highlighted in a bigger text. All right. You can see after we plot that. So first I'm checking for the label equal to 1, right? Selecting the data set and a column. And in that, I'm checking label equal to 1, right? So I'm going to use this word cloud, this guy, and giving some parameters like a height, how much height I need, and width I need, what is the background color you want, and how many words you want to print, right? So this dot generate will take this spams data, this spams, because we have already filtered the spam data. I'm going to pass it here. Then I'm going to print it. So this is how you can print. And here you see that what are the loaded words, right? So call, number, things like that. So here you can understand by looking into this word cloud. So claim, these are all basically what? Spam data, right? And we need to check whether we are going into in the right direction by looking into this data. Claim, free, price, call, dollar symbol, right? Cash, win. So what it indicates? It indicates that, okay, so this is, we are going in the right direction because we see this win, claim, all this text we can, most of the time we can see in the spam messages only, right? You know, if the friends and a family, why we will say that to win, right? So free, a prize, claim, we never talk in these terms. Even if we talk maybe once in 1,000 times, all right? But here you can see these are more number of times that because they are appearing more number of times in the spam message, that is why it is highlighted. All right. So it indicates that, yes, we are going in the right direction. So same thing, I'm going to do this for the hams data. Everything is same except the messages, labels. Here I'm using labels equal to 0. So I'm using the same code. Nothing is going to change. and I will execute. Now you can see these are the normal message texts. So you can see that, okay, think, time, want, got, need, come, no, love, right? No, which spammer will say love and things like that, right? Home, why do we say home and all? But these are all basically friends and family messages, and it gives the same impression, right? It comes from someone who is close to you, right? So that's how you can interpret this. This is basically ham data, right? All right. So let's move on. Now what I'm going to do, I'm going to use a TF-IDF vectorizer, right? So in order to do a vectorization. So TF-IDF vectorizer I'm going to use, and also I'm going to build a multinomial NB model. So that is from a new bias and a train test split as usual, and accuracy and other metrics. All right, we have seen how TF-IDF vectorizer works. So multinomial NB works on a probabilistic factor. So it will check the each and every data and compare with the existing data, and comes up with a gives the label based on the probability. All right. So I'm not getting too much into this one. So, but at the high level, I can say that multinomial new bias algorithms works better for text classification. Right. TF-IDF vectorizer I'm going to instantiate. Multinomial NB also I'm going to instantiate. And I will use this TF-IDF. Let me take this. So this, whatever I have instantiated, I will use this, and I will say fit underscore transfer. So what need to transfer? I need to transfer the entire messages. So I'm going to store in this features, right? So right now we have messages in the form of text. So going forward, they're all going to be numbers. So those numbers I'm going to store in this X. Obviously, we have Y, which is a label. So X and Y. All right. And yeah, we know that how machine learning, how to build a machine learning model. So now X is having all vectors, Y is having a classes. So it's as usual what we do in machine learning, same concept we are going to apply here. So splitting data into train and test, right? And X features and labels. So now I'm going to use this new model, and I will train the model using .fit method, where I will pass X train and Y train. Then I'm going to predict here. And predictions are over here. And I'm going to check the accuracy score, Y test and Y prime as usual. Nothing new here. All right, let me execute. And let me execute this also. So you can see 97% is the accuracy score. And if you want to check the classification report, precision recall, so you can use the classification report as a metric, and you will get F1 score, recall, precision. So all these data we already know in the machine learning, how to interpret all of them, right? So if I want to build a confusion matrix, like how many true positives, false positive, false negative, and true negative, I'm going to use a confusion matrix, and as usual, my actual labels and predicted labels. So I'm going to generate, this is just for a designing purpose. You don't need to worry about this. So this is how it looks like. Here the data are not coming out properly. So what I will do, I will just use a confusion matrix. That is basically this data, right? So don't worry about this. This is just for highlighting in different colors and things like that. Otherwise, this is the data. 1202, true positive, right? So this is basically true positive. This is a false positive. this is a false negative, and this is a true negative. We don't have any false positive. It means that we did not predicted any messages positive, which are in reality it's a false, right? So which is a good thing. And we have predicted some messages negative, but in reality they were a positive, right? So this is something that we need to look into, right? So these are the right data which we predicted. So yeah, based on this, anyone can analyze and try to do some more pre-processing if you want to bring down this. Maybe this is the final number. We don't know. It's all depending upon how we do pre-processing and how much volume we have in the data set. All right. Yes, this is all about spam detection. I hope you got the idea here. Yes, thank you for watching this video, and I will see you all in the next video. Keep learning. Thank you.